through the mathematics. And in math right now, we're talking a difference of mathematics versus arithmetic. Arithmetic is the rote skills, definitely necessary, but we used to put all of our emphasis just on the arithmetic, and then we realized there needs to be a balanced approach. I'm going to show you how the kids use manipulatives, and I know as first grade parents you think it's obvious that 6-year-olds and 7-year-olds use manipulatives. They're using manipulatives up through 9th grade. They are the visual understanding. I don't know it well, but I've read the brain research. When you can visually understand the mathematics of it, that's what helps you understand it, and it makes you understand it and remember it. It makes it so you can use it. So let's get started. Any questions? This is a workshop where you do the work. I'm going to follow along with you. You will be talking with your table mates to see if you agree. And today's work, there's going to be a lot of times where there are a lot of ways to solve the question or to show your work. That is always true. There's usually only one right answer, although it depends on the question. We're not saying we're accepting wrong answers, but how you get there can be of several different avenues. So let's open up our pamphlet. He had that just right.
Don't worry.
This is technology. You know, I discovered it didn't. I had it perfectly set up to charge. Okay. First of all, one of the requests is that there's a lot of language. So I've given you a vocabulary page. It just tells you some of the language. In first grade, these are helpful, but we do not test kids on the language. But when we have the language, we can talk about it more clearly. Instead of saying, oh, that thing, or I did it like this, the kids can use it. We know that kids interested in dinosaurs learn the word Triceratops and Tyrannosaurus Rex, no problem. Kids are absolute sponges. They can learn this language when it's useful to them. So we use it, but we would love that they do, they mimic us, they want to use it back, but we don't test them, it's not required. This is about the mathematics, but they're really capable. A lot of kids are using the term compose and decompose, put together, take apart. Those words are just as easy, that we use them all the time. And we never leave them isolated. We would never say compose two numbers and make them figure out what we mean. Place value is a very big issue now that they've gone into double-digit numbers. They need to know the difference between ones and tens, and they are closely heading towards second grade where they're going to need the hundreds. But before we don't ask them to memorize it, we build it, we build it, we build it. Number or numeral form just shows you what it is. Unit form, all of these. The make 10 is a strategy. Addition sentence is what most of us would call an equation, but at first grade we don't. We tend to call them math sentences, addition sentences. Greater than, less than, equal to. They make a lot of cute diagrams with alligators and dots. Understanding the idea of it is more important, but they need to know the representative symbol that goes with it, and that's probably the bigger challenge for most kids. And down at the bottom there are examples of what we mean by a quick 10 and a number bond. I think by this time of year most of you recognize these. I hope this is better on your paper. We are having a discussion about number bonds that I'll talk to you in a few minutes. The quick 10s is probably the go-to strategy right now for most kids if they need a picture. The arrow notation, or I tend to use the term the arrow way, this is probably the little bit more advanced way of showing it, and I'll show you why. It's for kids who are now able, when they say, oh, I just know it in my head, and we want to say, well, but what did you do in your head? The arrow notation is a way for kids to be able to write down what they did. It's instead of writing a lot of equations. So I'll show you that as we go. Let's move on to our word problems. These are the ones by the end of first grade, kids are reading. We do read them to them, but after we read them to them, these are problems they're supposed to be able to do independently. I do want to show you how we're using our manipulatives. So if we read that Nikhil has 12 toy cars, Willie has 4 toy cars. When Nikhil and Willie play, how many cars do they have together? You've got manipulatives in front of you. How would you show me that you understand this problem? What would you build with these blocks? You may still have colors too. When we're given colors, most kids will build them by color so that you can see that Nikhil has 12, Willie has 4. We can see that we understand that, and if we want to know how many they have together, we put them together and we could count. That's exactly what we're talking about by showing. So that was more towards the beginning of, well, mid-year. How would we do this as a drawing? When we ask them to show us visually, we start with the manipulatives. So first of all, what does this look like? Oh, it looks like a long rectangle. Well, who is this? Well, I better keep track. This is Nikhil. I can put an N. At the beginning, they might draw 12. They could write 12, or often they put 12 dots. I'm going to put mine outside just because I wrote my 12 too big. 6, 7, 8, 9, 10, 11, 12. And then I have Willie, who has 4 more. This is now just turned into a bar diagram. I'm sorry, tape diagram. Bar model is the old wording, tape diagram is the new. As you can hear, I can mess them up. This is the tape diagram. So now we have a visual understanding of what the child is thinking. Most kids at this point would probably circle the 10 because they recognize it as an easy number. They would have 10, 11, 12, 13, 14, 15, 16. They then need to write that addition sentence. It would be 12 plus 4 equals 16. And the very last thing that's required is the answer sentence. That last sentence is imperative. It's a little bit of a double check of am I really answering the question that was asked in the problem. This is a very simplistic problem, so it's not as obvious, but when we get to others, you'll see where, oh, they could have just put them together, and actually that's not what the question was asking. So we've gone from needing to build it to be able to see the bar diagram. On the next one, Tamara has 14 grapes. She ate 8 of them. How many grapes does she have left? Some kids are going to be building. Some are going to be able to go straight to drawing. I always double check. She has 14 grapes. She ate 8 of them. What's going to happen? We're going to take if we take 8 away, how would I do that? And here it is. Here, or I can just take 8 away. I can slash them out. If I count right. And I've got my answer. At this point, I would not call that a tape diagram, and I don't care. We're giving these as tools, not as requirements. So if a child left it like this and then wrote, I'd be perfectly happy. And the last sentence, Tamra I have a feeling I counted this wrong. 1, 2, 3, 4. No, it's right. Yes?
You just write 14 and 12 out. Is it either way wrong, or is it best to do it like that, or is it best still to do the 10s and then do it like sort of 4?
Okay. If I understand, you're asking me whether writing the dots or just writing the 12?
No.
No.
So you have 12 dots. Would it be, is it best to do the 12 dots in a row, or have 10 dots in a row and then 2 below? Like just separate 10s to make like quick 10s?
Yeah. I think usually, put this over here. First of all, either one is correct.
Yeah.
Would I, as a teacher, I would probably keep showing, I might even do 5s because those are so recognizable. I might draw it like that where they're apart so I can see it. Not as much underneath. If a child does it underneath, I mean, there's just reasons for doing 10, and tape diagrams tend to be, all I can say is almost a single layer. Again, if they're doing it right and that makes sense for them, we're going to accept it. I'm going to keep modeling it in a single line.
Okay.
And the dots are for the...
It was more if the 10s stood out.
Yeah, and I know there are some teachers that definitely leave this space. I don't think, oh, I'm sorry, you can't really see that. I don't think many teachers are doing colors. That just becomes, I do colors with the blocks. I don't do colors on the paper because that is amazingly difficult sometimes for first graders. So yeah, any way that you can see that quick 10 is a good idea. I mean, I did circle it here, so, but the spacing is up to them. And what will happen is we're moving on. There are kids that don't need the dots. They would put 12 here and they would put 4 here, and that would be perfectly fine. But we need the 12 and the 4. We need some representation. And I know there's been discussion about communication. We need to understand what's going on in the child's head. And a child might know that's 12 and that's 4, but if they're not communicating it to us, then you're asking the teacher to take a guess. So we need the labeling of who or what. We need the numbers somehow represented. On this one, I don't know. You could turn this into a bar diagram, tape diagram. You could do that, and you would then put eaten, uneaten. And we don't even really expect the whole word. I mean, it's just we want to know what the child's thinking. And really, in first grade, we are expecting some sort of visual, even if they can go here. Yes? Right. I mean, we've got them.
At what stage do you expect them to make this transition?
That is very dependent on the child's understanding of the math. We don't have a particular time. We're expecting visuals. I mean, welcome, Mr. Waters is here from 6th grade. Mr. Waters, do you expect visuals in your class?
We go from using manipulatives in 6th grade to the representational, the graphs and diagrams, to the abstract where you have just numbers and labels. So this is perfect preparation for this.
But yes, we do understand that at some point the visual, that that's when they have complete understanding. So there will be some kids who are still drawing the dots, and there will be some kids who are just using the numbers. On word problems especially, we are asking them to show us the model that they're thinking about that makes them understand.
So they have to make sure they understand visually or physically to be able to reason their answers.
If the children are struggling with these type problems, they may never get this visual written down. If they're struggling with the manipulatives, we'll need them with the manipulatives. By the end of first grade, I would expect these two to be drawn pretty much the way they are, not necessarily with the dots. I'd say that's where the kids are probably at both of these stages. We probably got some kids doing the numbers and some kids doing the dots. These two are the simple ones. Let's get to the next one, and now you'll see where the picture comes in. Oh, wait a minute. Let's skip, to be honest, number 3 is kind of more of the same. Let's go to number 4. Let's go to a good problem. And this is where our reading comprehension is important. Tamara has 6 more goldfish than Peter. Peter has 10 goldfish. How many goldfish does Tamara have? So immediately you need to stop because the information is not particularly in order. What we really know comes from the second sentence. So could you please build what you think how this would work? So most of us looking around built something like this. We started with the Peter's 10, and then Tamara had 6 more. We really can't start with that 6, and that's where you have to get to. What do you really know? Where's the main point of information that you know? This can be drawn exactly like we built it. Right, Peter has 10. And then we can do Tamara has 10 and 6. And then sometimes people do Peter has 10, Tamara has the 10 and the 6. Excuse me. This would be 10 and 6. Both of them show how much she has. And again, it's not right or wrong, it's really how the child visualizes it.
This is particular problem when we have a problem at home. This increment of 6 more, it seems like really hard to understand for my son. And if you put this diagram and I'll say which one is down and which one is Peter, he'll say Peter has 10 and how many down? He'll say 6. He'll say 6.
So you need to go back to then build what Peter has.
This increment part is really hard to explain.
And that's why we need to do it with the manipulatives, and we need to go back, and if he just hands you 6, you've got to go back, but it says he has 6 more. And you need to,
It's a language that we can use to make it easier because we have fewer and more less and more.
and I'll tell you the language is very purposeful because we want them to get to this understanding. If I'm not going to be able to just switch it, but when we make the language much simpler, the mathematics also became simpler. We want this idea that they can hold on to, that there's a set amount, and then there's some more. Yeah, and it is tough. That's why we're doing it with the small numbers. You know, they're working with numbers up to 100, but in the word problems, they're only working with numbers up to 20. Because it's not about the numbers, it's about the understanding of what's happening. And that's why the building of it and the drawing of it is so important. Could you go ahead and do number 5?
How would we write this in numbers?
Oh, thank you. I think this ends up, how many goldfish does Tamara have? Tamara has 16 goldfish. Or did you want, I mean, it really is 10 plus 6 equals 16.
Okay.
Yeah.
Yeah.
I think number 5 is pretty much the same problem. So we start showing them to you so that you've struggled through one, you try it again, and hopefully it makes a little bit more sense. 5 sharpened. And to go back to the last question, I think if a child has struggled, to me, this illustration is going to help a child more. The child who sees it this way is probably understanding it a little bit more intuitively. So we've got Peter with 5 sharpened pencils. If he has his 5 sharpened pencils and 8 more, I can't read my question. How many unsharpened pencils does Ben have?
More than is probably the key which kids need to understand.
Mm-hmm.
Because otherwise they might say, oh, he has 8, it says 8 more.
There-
So maybe
most-
it's just 8.
When kids are just doing arithmetic, they see a 5 and an 8 and the answer is 13. But they're not
Which is
knowing
actually correct
why.
in this case, yeah.
Yeah, it does, but
Or they might just
We're
say
going-
it's 8 unsharpened pencils. Because it says 8 unsharpened
Right.
and ignore the more.
yeah. Okay. So I want to get to this last one because this is where just grabbing the numbers isn't going to work. Shanika did 11 cartwheels during recess. Kim did 6 more cartwheels than Shanika. How many cartwheels did Kim get? Oh, yeah?
Yeah, because I have a question. For the number 5, you use first the 5. I know this is the sharpened. And now 8 more are unsharpened, which means 8 plus 5.
No,
and then
not-
I have the
not-
number of the unsharpened.
8 more, it's not 8 more unsharpened, it's 8 more than the sharpened pencils.
Yeah, okay, but I know 5 are sharpened and 8 more unsharpened than sharpened. So I know 5 is sharpened, then it's 5 plus 8. Then
Yes.
I have the total number of unsharpened, right?
Yes.
Okay.
So I'll go ahead and write that down. I mean, it was,
Okay, just in case.
yeah, do the 5. Mm-hmm. And this is the word problems. That's why that's why we're only doing a few of them at a time, and we're having the kids talk about them and talk about why is that so. The next one, the first part, is what we've just done 2 other times. We've got Shanika doing 11 cartwheels. Kim did 6 more cartwheels, so it would be the 11 plus 6, and this equals Kim. And this is where this answering the sentence of how many cartwheels did Kim do? Kim did 17. And then, how many cartwheels did Shanika and Kim do? I would almost like the word together in there. I would surely say that to the students. So now we have Shanika, and we have Kim, which is 11 plus 17. And I broke the first grade rule. That number is going a little too high. The kids would not have one that high because we're supposed to stay within 20. So we would have an answer of 11 plus 17 equals 28. They did but this is where they're answering 2 different questions off the same information, and that having to write that sentence makes sure that you go back to the question that's asked. Sorry. So these questions got considerably harder as we went down. We don't do this in one day with first graders. You're in a 6-week course here, remember. So I didn't give that in my prelude. Please, they're working with this every single day. They're kind of used to the manipulatives. It's 6 weeks. They have time to do this, and you're getting it in 6 minutes. Did I make it? Yeah.
I think actually it was already answered, so I'm not sure. The answer to number 5, is that 13?
I'm sorry, is it what?
13, so how many unsharpened pencils does Ben have? Ben has...
Oh, yes. So this is the communication we're now expecting from them.
She does 17 and she does
Okay, is this making sense? I also want to point out that this tape diagram is a representation of part whole. And if kids can recognize, if they have 2 parts, they can figure out a whole. If they have a whole in one part, they can figure out the other part. It's very similar. There's a relationship with number bonds. That's what we do with numbers. We take them apart. And these are not addition or subtraction problems. Especially when we get into the world of, oh, that's a subtraction problem, and a child is adding up and all of a sudden goes, oh dear, I'm doing it wrong, and they shut down. Addition and subtraction is simply how you get to the answer. That's the arithmetic. If you know that you have 5 grapes and you want 13, to some people that's 13 minus 5, I'll get 8. To some kids, that's 5. I can count up 5 more, that's to 10. 3 more, oh, that's 8. No, they'd have that on paper so they can see what they're adding up. So this is this other idea that this shows that they comprehend what to do. How they solve the arithmetic can also be very individual. I mean, addition problems, really, there's no other way to do it. But the subtraction, there's really no such thing as a subtraction problem. There's always a way to do it with adding, if you've got the information. So we don't say that, and I've seen just faces fallen when I've been working with a child here, seeing that they're going to do it with subtraction, and then you say, oh great, you're subtracting, and the kid next to them just falls apart. They had a perfectly good adding up strategy, but they just heard the teacher say it was subtraction, and they're now lost. So that's why we give a lot back to, and how are you solving it? Because there's so many ways of doing it. I mean, first grade, they really only have addition and subtraction. They've got a lot less to do it, but by the time you get into the upper grades, that does it. That was, yeah.
And when they get to middle school with negative numbers, they're going to learn that they can add negative numbers and subtract negative numbers. And when it comes to subtracting negative numbers, there are 2 ways to do it there. You can subtract the negatives and turn it into adding the odds. So all of this is building.
Yeah. And all of it's about, excuse me, all of it's, again, it's having that tool chest of many ways to do it, and you pick the appropriate tool. Instead of a single tool, and if you don't know how to use it, you can't do anything with it. The rest of today is really showing you the strategies that your kids are being introduced to, so that you understand what it looks like. And I mean, the first graders have asked me, the teachers have asked me to say a few things. On the homework, the kids are really welcome to solve the problems. The vast majority of time, they're welcome to solve them any way they can. Every once in a while, we might want them practicing one particular strategy at home, but very rarely. Usually we want them using what they're comfortable with and what they're knowing. Not necessarily in class. We teach them the first strategy and they love it. We sometimes have to push them to try a different strategy, and we do that in class. It's like, for today you're going to practice this. I know that strategy worked well for you, but let's practice this. Let's see if you can do that. We always make the analogy to sports. You've got to be able to shoot the basket from the left side and the right side. You've got to be able to make the free throw. So, but when it goes home, we really just want them independently doing what they can. It's not your job to be doing the teaching. We thoroughly appreciate your support. We understand you wanting to be there for the kids. But if they're totally lost, the teacher needs to know that. And if their homework comes back perfect and clean, we think the child's got it. So yes, it's great that you work with them, but just getting them to the right answer really isn't doing them any service if they're not understanding it. Anytime there's a question, first, if there's any tears, stop. Especially if it's your tears, but it's not meant to be that way. I have a pet peeve. They said, oh, you've got to bring the games back into math to make it fun. I will tell you, when you watch kids learn, they're having fun. The brain is wired to want to learn. I get the struggle can be tough, but boy, when they get it on their own and they finally understand it, you will just see their faces light up. I was a social science history major. When I told my father I loved teaching math, he about fell out